Good afternoon, all of you. Uh,
Afternoon, ma'am.
so yesterday we were discussing about the packet filtering firewalls, right? So we concluded our yesterday's lecture on the weaknesses which were there in our packet filter firewall. Also, we were trying to discuss what are the possible attacks which have uh, affected the packet filter firewalls, as well as what are the countermeasures which needs to be incorporated in these packet filtering firewalls. So one of the case which we were discussing was we'll discuss by case basis. So the first attack is the IP address spoofing. Now I don't need to elaborate what is IP address spoofing. How the IP address spoofing attack happens in a packet filter firewall. I'll give you a scenario. So let's say that there is an intruder who normally resides outside the internet or outside that network domain. Now, when that intruder who is present outside the network domain transmits the packets to the internal host, where is that internal host present? Your internal host is present in a different network. Okay, so there are two networks. One is referred as an inside network and the other one is referred as an outside network. So your attacker is present on an outside network and he transmits the packets to that inside network. Okay. Now when he is transmitting the packets, he would transmit it with a motive of having a source IP address spoofing done. Now when he will be doing the spoofing of the source IP address, he would be trying to add the IP address of a client who is present in the internal network. Okay. So the attacker is doing this with a hope that even if he's using a spoofed address, your firewall will allow the penetration into the system because it has the valid IP address which is there onto the network. Also, since he's sending the packet according to the valid source IP address, since your packet filter firewalls are only filtering the rules or having the rules which filter the packets on the basis of IP addresses and the port numbers, so your PFF will allow the packet. So possibly what is happening is that if there is any packet which is originated from an outside network and is directed to an inside network with the spoofed IP address, this would be assumed that your packet will be allowed to enter into the system. Clear? Any doubt?
No, ma'am.
Okay. So such case, if I want a defense or what is the countermeasure which needs to be incorporated to avoid certain situation. So the countermeasure which is there in the PFF is that when the firewall is configured, your firewall is configured at what end? It is normally configured at the router interface. Okay, in considering this example. So what would the rules be incorporated and how would the filtering be done? Your filtering would be done with the concept that even if certain case has arisen, that onto the router which is connected to the external network, if a packet comes and has the IP address of the internal host, your packets would be dropped. Clear? So the countermeasure over here is to discard the packets which have the inside source address. Okay. And if the packet has arrived on an external interface, so here the external interface is the router which is connecting the internal network with the external network. Okay. And it would only be effective into the case when you are implementing it at the router which is external to the firewall. Clear? So you have the placement in, if I go from left to right, the placement is like first you have internal network, then you have firewall, then you have the router, and then you have the external network. So whatever packets which are originated from the external network would come out onto the router. Okay, your router would further forward the packets to the firewall, or you can say that the firewall is part of the router. So whenever the incoming packets at the router end have the IP addresses of the clients which are present in the internal network, this is obviously a malicious situation. In that case, your IP address spoofing would be prevented. Clear? Moving on to the second attack, which is source route attack. So here, in case of a source routing attack, the source station specifies that the route that a particular packet should actually take would cross the entire network domain. And it would be hoped that whenever this thing is happening, your packet will bypass all of the security measures which do not analyze the source routing information. Okay, so normally what we were doing is that your packet filtering firewall was working on the concept that you'll only find out what is the source address and what is the destination address. And you're not considering the route which your packet is following. Okay, so if you're not considering the route to filter out the packet, individual PFFs which are installed at the router would only be considered with the those five parameters which are there in PFF and filter out the packets. But here the other concern also is that what route is the entire packet taking from source to the destination. Okay, so if you do not have such kind of information incorporated in your PFF or any such defense which deals with the concept of identifying what is the source routing information, this can lead to an attack into your system. Okay. Now, what countermeasure had PFF introduced? The countermeasure which was introduced is that we'll discard all of the packets which are considering such sort of behavior. So those packets which are more inclined or more said to have lesser number of information, or it also deals with the routing information, then you would discard the packets at the PFF level itself. Okay. The third point, which is the tiny fragment attack. So normally when we are transmitting the information, the fragmentation or the IP fragmentation comes into the role. Okay. Now this fragmentation can be considered as a vulnerable point and it can be exploited by the intruders also. Okay, so now what the intruder does is he uses this IP fragmentation option to create extremely small fragments, and he tries to force the TCP header information into a separate packet fragment. Okay, so now what normally happens is that when you have to send the information and it is the message which needs to be sent is larger in the acceptable size, what you will do or what the router would do, he would create the fragments of the packets. Okay, now technically what happens is that your fragments of the IP packets when created, your IP header would also be divided. Clear? So if your IP header is divided along with the fragments, so what normally happens is that your IP header, or I can say the entire TCP header information, is only part of your first packet. Rest of the packets consider or have the other informations which are required. Okay, so when a normal communication is happening, as soon as the PFF gets the first packet or gets the first fragment, your first fragment will always be valid. Clear? Why would always be valid? Because it would have some information which is a valid information. Okay, And if the first packet doesn't have a valid information, your PFF would discard all the subsequent packets without checking what information is there. Clear? So this is a normal concept which happens in the case of IP fragmentation. Now, if this thing happens, this can be used as a vulnerability and it can be exploited. How can it be used? Since only the first packet was checked by the firewall. Okay, so what can be done is that the intruder can modify the first packet in a case that it will have the valid information. However, the other subsequent packets or the subsequent fragments have some spurious content within it. So whenever the PFF checks the first one, he would find that it is according to the rule, okay, and all of the other packets would be passed through without checking what information is there into those subsequent fragments. Okay, now what is the countermeasure for this? Okay, the tiny fragment or this tiny fragment attack can be used, I'm sorry, you can have a defense in such case that whenever the fragments are created, okay, so some part of the TCP headers information needs to be present in the subsequent packets also. Clear? So what does it mean that even if you're doing fragmentation, there should be some amount of TCP headers information present in each of the fragment. Okay, so that is they are defining predefined minimum amount of the transport header should be there in each of the packet. And here, if the PFF finds that the first packet is not having additional amount of information, your first fragment itself will be rejected. Your filter which is there would remember that the first packet has been discarded, and similarly the subsequent packets will also be discarded. Clear? Any doubt? Okay, so we'll go ahead with the packet filter, with the next filter. So if I want to summarize what is there in a PFF, we said that the PFFs were working in a low level. It was not handling the upper layers protocols, or it was not handling the applications which are part of the application layer and all. So all of these were possible drawbacks of the PFFs. These were tried to be rectified in the other firewalls. Okay, so now moving on, we'll come on to the next firewall, which is the stateful inspection firewall. Okay, now since I said that the PFFs were working on the lower level, they were not considering any higher layer, layer information, or you can say that they were not taking into concern the higher layer context. Okay, so now the context over here normally means that it was only considering the information which it was programmed for. So, for example, let's say everybody knows what is the standardized application that run on the top of the TCP, which is SMTP. Okay, so you use SMTP as an email transmitting system between the client and the server. Okay, so you have a proper TCP connection established between the client and the server, and SMTP session is created, and the data gets transmitted. Fine. Now, the port numbers which are used are 25, and which other port numbers are used? What is the TCP port number for SMTP server is 25. To run the SMTP application, you'll use 25 port number. Okay, and similarly, you'll require the port numbers at the client side to run SMTP client. In that case, the port numbers which will be used will always be between 1024 and 65,535. Okay, so whenever the TCP communication happen or an SMTP session is created, either of the numbers or either of the port numbers between 1020 and 65535 would be accepted at the client side, and at the server side you'll have 25 port number. Okay, so in general, when an application which uses the TCP creates a session with a remote host. Okay, so here it creates a TCP connection in which the TCP port number for the remote application server would be a number less than 1024, and the TCP port number for the local application would be a number between 1024 and 65535. Okay. Now, the number less than 1024 are obviously known as the well-known port numbers and are normally assigned permanently to the specific applications. That is why I said that 25 is assigned to SMTP server. And when we are talking about the client side, then the numbers which is 1024 between 1024 and 65535 are normally allocated dynamically and have very temporary significance. That is only for the lifetime of that particular TCP session. So here, a simple packet filtering firewall would permit inbound network traffic on all of these high numbered ports for TCP based traffic to occur. Clear? That is, on all of these port numbers which is given over here, there would be an inbound traffic allowed. Okay, now when the entire inbound traffic is allowed on all of these port numbers, this thing would normally create a vulnerability that can be exploited by the unauthorized users. Here, the stateful packet inspection firewall or the stateful inspection firewall would make more stringent rules for TCP traffic. Now, whenever these rules are created for these TCP traffic, these rules are created into a directory and are normally for outbound TCP connections. Okay, so there isn't any table over here. Uh, so I'll create a table. So see, if you have a stateful firewall connection state table, what normally it has the source address. Okay. The other thing which it has is the source port number. Again, you'll have destination address and the destination port number. Followed by that, it would have one more information, which is connection state. Okay, so let's say the first entry is there for your X source address, and it is using we said that it would use the port numbers between 125 to 65,000. So it used 1030 port number. Destination was, let's say, Y. Destination port is, for instance, 80. And then you'll have a connection state which is established. Okay. Similar entries would also be created according to the sessions which have been created between the source addresses and the destination addresses. So all of these that is, these entries which are mapping the source address to the destination address would be the ones for currently established connection. Okay. Now here the packet filter firewall will not allow any incoming traffic to the higher numbered ports, only for those packets that fit the profile of one of the entries which are there in this directory. Okay, now the entire stateful packet inspection firewall will review the same packet information as whatever was done in the packet filtering firewall, but additionally, it will record the TCP connections and the information about those TCP connections. Now, what information would be there? Sometimes what would happen, these will keep track of the TCP sequence numbers to prevent any sort of attack based upon the, let's say, replay attack is happening. So that can be prevented by keeping the sequence numbers, or let's say it considers session hijacking. So these amount of informations or such sort of attacks can be prevented by keeping track of the connections which have been established and are partially open. Same thing which we discussed in TOS. Okay. Now there are some stateful firewalls which also inspect limited amounts of applications. For example, it inspects the FTP protocol, it inspects the IAM commands just to identify and track the related connections with the source addresses and the destination addresses. Okay, any doubt?
No, ma'am.
Okay. So we'll move forward to the other firewall, which is the application level gateway. So can you guys tell me that where would your stateful firewalls be considered as not so advantageous?
Ma'am, it does not care about the higher order layers like application, etc.
Are you sure it doesn't care about application?
It's only working on port and source address, but not what is sent. If there is a application
I said
vulnerability, it can
initially
be
that
exploited.
I also said initially that it is considering higher layers.
मैम बट एप्लीकेशन में अगर कोई वल्नरेबिलिटी है मैम उसको नहीं रोकेगा ना मैम ये
कौन से एप्लीकेशन में?
मैम जो भी हम लोग एप्लीकेशन अगर यूज कर रहे हैं उसकी
मैं
वल्नरेबिलिटी
टेलनेट यूज कर
इज
रही हूँ, अगर मैं टेलनेट यूज कर रही हूँ और टेलनेट के थ्रू पैकेट्स भेज रही हूँ, तो क्या स्टेटफुल कंसिडर करेगा उसे?
यस मैम करेगा क्योंकि पोर्ट नंबर के हिसाब से
सोच लो एक बार और अच्छे से, क्योंकि अभी टेलनेट कौन सी, टेलनेट तो एप्लीकेशन लेयर से काम करता है ना,
यस मैम
तो फिर अभी आप बोले कि हायर लेयर्स को नहीं करता.
मैम मेरा कहना है अगर टेलनेट में कोई बग है मैम उसका अगर कोई यूटिलाइजेशन कर रहा है वो नहीं ब्लॉक होगा
ओके.
आई मीन
व्हाट अबाउट इनबाउंड एंड आउटबाउंड ट्रैफिक? स्टेटफुल दोनों तरफ के ट्रैफिक को कंसिडर करता था या फिर एक ही तरफ के ट्रैफिक को कंसिडर करता था?
मैम आई थिंक वन साइडेड इनकमिंग
ओके. एनीबॉडी एल्स? उज्जवल, चंद्र प्रकाश, सो गए
Yes,
क्या
ma'am.
भाई खाना खाना खा
नहीं नहीं
करके?
ma'am. Yes, ma'am. No, what
But
I am saying is I will provide you the papers, all your family papers where we are posting the design.
somebody speaking? Where would your stateful inspection firewalls fail?
मैम फॉर ईच कनेक्शन देयर हैज टू बी वन एंट्री इन द table so
Yes,
it will take a lot of space
yes. There would be
and
memory requirement. Okay. Higher memory requirement in case of stateful.
yes ma'am
Fine. Anything else? One, you said that in some of the cases it is not considering the applications. It would not work for all of the applications of the higher layer. Any other
यस
thing?
मैम। मैम इनकमिंग और आउटगोइंग के लिए मैम अलग अलग एंट्री होगी क्या टेबल में, like
Yes,
because source and destination will be reversed, so एक for every connection there will be two entries.
yes. For every connection there would be two entries. That is why मैंने पूछा था आपको कि वो इनबाउंड टीसीपी कनेक्शंस लगता है या फिर आउटबाउंड.
ओके, थोड़ा सोचना पड़ेगा इसमें।
नॉर्मली क्या होता है कि स्टेटफुल सिर्फ आउटबाउंड टीसीपी कनेक्शंस को स्टोर करता है और रूल्स भी वो आउटबाउंड पर ही लगाता है.
बट अगर इनबाउंड पे हम लोग नहीं करेंगे तो मतलब फर्स्ट टाइम जो मैसेज आएगा वो तो हम लोगों को अफेक्ट कर सकता है ना।
हम ये बोल सकते हैं कि जो इनकमिंग ट्रैफिक है, इनबाउंड ट्रैफिक है, वो अगर हायर नंबर ऑफ पोर्ट्स पर है, मतलब कौन से हायर नंबर पोर्ट्स, जैसे वही 2024 से
254 से आगे
तो
65
वैसे
तक।
अगर उससे हायर पोर्ट नंबर्स यूज किए हुए हैं तो वो सारा ट्रैफिक उसको अलाउ कर देगा.
मैम दैट इज अ वल्नरेबिलिटी ना मैम, जो कोई भी इंट्रूडर यूज कर सकता है।
हम्म. किसी की भी इंट्रूडर किसी नॉर्मल यूजर की प्रोफाइल को मॉडिफाई करके या फिर उसको अडाप्ट करके वो पोर्ट नंबर्स यूज करके इनबाउंड ट्रैफिक भेज सकता है. Had it been a normal user, then it would not have affected. However, this thing can be exploited. Okay, then
यस मैम।
we'll go ahead with the next, which is the application level gateway. So in case of an application level gateway, this is also referred as an application proxy. Here, there are certain routers which have been configured as the relay router. So you can say that the routers which are there or the proxies which are there would be referred as application proxy or application level gateway, and these would act as the relay of the application level traffic. Okay. Now here the user contacts the gateways using the TCP or the IP application. So for instance, he uses Telnet or he uses FTP. Now, if you recall, when we were discussing PFF, I said that user authentication is not done in PFF, neither it is done in stateful. That drawback of theirs is handled in application level gateway. Okay, so whenever a user tries to contact the gateway using any applications of TCP or IP, for instance, Telnet or FTP, and as soon as the traffic comes at the gateway, your gateway would ask the user for the credentials of, okay, so it would ask the user for the name of a particular host which he would try to access. Now, when the user responds and he gives in the valid user ID and authentication information, further the gateway would forward the request, or the gateway contacts the application which is running on that particular remote host, and then he relays the TCP segments containing the application data between both of these endpoints. Okay. Now, if the gateway doesn't implement the proxy code for a very specific application. So for example, whenever the request comes in at the gateway and it is configured, the request is for accessing FTP server, but it doesn't have the configuration of FTP at its end. It doesn't have the proxy code for FTP. In that case, we have to say that the service is not supported by the gateway itself, and your message will not be forwarded across the firewall. Okay, so whatever services the user is trying to access at the remote host, if the application gateway or the firewall present is not configured to handle those requests, even if the user is a valid user, the segments will not be delivered to the destination host. Okay, that is why it is said that the gateway needs to be configured to support very specific features of an application which your network administrator considers acceptable. Okay, and there can be multiple features which are not acceptable by the network administrator. So if the request comes in at the gateway for handling those packets, in that case, your gateway would deny all the other features in for which it is not being configured. Okay, so now with this aspect, we say that the application level gateway is more secure than the previous ones. It is more secure than the packet filters. Fine. So here we are trying to have the cases which are very less crucial and are, let's say, very choosy in case. So we are only forbidding many applications. We are forbidding many applications at the TCP and the IP level, and the application level gateway which has been installed will only pass the packets on the basis of scrutinies and the application will with which it has been configured. Now the other thing which the application level gateway does is that it logs and audits all the incoming traffic at the application level. Clear? Now with this you have two important information which have been communicated till now. Your processing will be done at the gateway. Okay. How the processing would be done? What could have happened is that the user's request, whenever it comes at the gateway, that request would have been directly forwarded to the server or the host to handle. Instead, what is being done at the gateway itself, the first level of processing is done. That we can say that there is an additional processing done at the gateway itself. Okay, so this additional processing overhead would be there for every connection, whether it is a newer connection or whether it is an older connection, whether the user has already been authenticated at a previous instance or whether he has not been authenticated. Every time that additional overhead which is there onto a connection would be there. This thing is a prime disadvantage of the application level gateway. Okay, so that is why there are two connections referred as two spliced connections between the end users with the gateway at the splice point, and the gateway must examine and forward all of the traffic in the both direction. So same case here, previously what was happening that the traffic was only originated at one, sorry, was flowing from one direction in some of the cases. Here the traffic is two-way. You can examine and then forward it in either of the directions. Okay, now this is the prime disadvantage which was offered in case of a application level gateway. Okay, now if I want to summarize what are the advantages and disadvantages, first advantages I can say that the concept of information hiding is there in an application level gateway. Okay, the other thing which I can say is that this has a robust authentication system and proper logging is happening. We can say it is cost effective. Okay, it has less complex filtering rule which were there in the previous two of the cases. Okay, if I come to the disadvantage is that if I pick up an application which is telnet, so normally what happens is that your telnet requires two steps to connect. Okay, it would be that either an inbound connection is there or it's an outbound connection. So for both of the cases, you would be requiring authentication. Okay. The other drawback is that user needs to connect with the firewall every time. Rather than connecting with the host directly, he'll be connected to the firewall first and then his packets would be relayed or forwarded to the actual host. This complicates the process more. Clear? I hope there isn't any doubt till now.
Ma'am, in this also there will be overhead, right? Because it is first making two connections, right?
Yes.
Standing in the middle
Yes.
between the external and the internal.
Yes.
So it will create a additional storage as well as overhead for calculations.
Yeah, storage, we can, yes, it would create the additional storage, but we cannot compare that stateful में ज़्यादा storage required होगा या फिर application level में ज़्यादा storage required होगा. हमारे पास इसमें फैक्टर एक एड ऑन जो हुआ है वो ऑथेंटिकेशन का एड ऑन हुआ है. तो अगर मैं ऑथेंटिकेशन के फैक्टर को एड ऑन कर रही हूँ तो ऑब्वियसली मैं मानकर चल रही हूँ कि दैट एट सम ऑफ द अदर प्लेसेस यू वुड बी हैविंग मेमोरी रिक्वायरमेंट्स which due to which only you are able to securely access the applications. Okay, so
Yes, ma'am. It is much secure.
yes,
Yeah,
even if there is an overhead, but that overhead may be considered that it is a nominal overhead.
Considering that it is making it
Yes,
much secure by adding authentication.
yes. Considering that it is much secure than the stateful by adding the user authentication.
Yes, ma'am.
Okay. The final one is the circuit level gateway. So same case here also. In case of a circuit level gateway, we can say that it is a standalone. It sets up two connections. One would be for an inside user, and the other one would be for outside user. Again, we can say that it would relay the TCP connection at some of the other cases. Okay. Now here the major thing is that there would be no filtering or processing done at the gateway level, or you can say that no filtering or no processing is done by the gateway. Okay, so if I find out the case of the circuit level gateway, here there would not be any end-to-end TCP connection which was there in your application gateway. वहां पर दो एंड्स बने थे. एक एंड बना था यूजर और फायरवॉल के बीच में और दूसरा बना था फायरवॉल और सर्वर के बीच में. ओके, सेम केस सर्किट में, सॉरी, वहां पर वही कनेक्शन फॉरवर्ड हुआ था. However, in case of a circuit level gateway, there would be two connections. One between the gateway and a TCP user, and the other one between that gateway and a TCP user on the outside host. Okay. Now, when the two connections are established, your gateway would relay the TCP segments from one connection to the other without examining the contents which are there into the packets which are flowing. And the security functions which are there would further identify what is the validity of the connection, determining whether the connection is allowed or not. Then your security functions would be activated. So previously what was done, when your packets were being forwarded, your packets were being forwarded with proper inspection. Okay, here in the circuit level gateway, as soon as the connection is established between all of these three individual clients, or sorry, two clients and the gateway, whatever packets needs to be sent will not be delivered only to the gateway. Instead, they would directly be delivered through that tunnel created to the destination host. Now, if I want to discuss what is the usage of a circuit level gateway, we can use a circuit level gateway in a situation in which the system administrator normally trusts the internal users. Okay, And in such case, the gateways can be configured to support application level or the proxy services or the on the inbound connections and various circuit level functions for the outbound connections. In such configuration, what would happen? The gateway can incur the processing overhead of examining the incoming applications data for forbidden functions, but does not incur that overhead would be done on the outgoing data. So for the implementation of a circuit level gateway, there are packages like SOX packages there, which is there in the RFC 1928, I guess. So this is the SOX package, which is actually an implementation example of a circuit level gateways implementation. So I'll send you the document which has a section which talks about SOX and what are the TCP and the UDP ports which this packet uses, and you can go through it. It's very small detail that what are the individual components of the SOX. It has a server, it has the library associated. It normally runs on it is a Unix based firewall, and it is also implemented on the Windows system. Normally, when we are talking about SOCs, there would be standard client programs like FTP and Telnet, which will use this protocol for relinking of the TCP-based client applications. So that you can go through it. It's a very small paragraph. So every time when you're using SOCs, you will be using authentication for communicating the data. Sometimes you can use TCP for connection, and sometimes you can use UDP for the exchange of the data. Okay, so I'll send you the document, and we'll discuss two more topics. One is the firewall basing, and the final one is the firewall location and configurations. So normally we'll talk about the DMZ networks, and then we'll be done with our syllabus. Okay. I hope you don't have any doubts as of now. If you have, you can discuss it in tomorrow's class. You'll have it from 12 to 1.
Okay, ma'am.
Okay, ma'am.
Okay.